Welcome friends. In today's lecture we are going to discuss different methods of linear measurement and angular measurement in the subject of metrology. We'll start with the linear measurements, and in linear measurement we will discuss Vernier caliper in details as well as the micrometer also. Then we will see the remaining methods of linear measurement in short, like slip gauge, height gauge, dial indicator, bore gauge. So let us start with Vernier caliper. Here you can see the photograph of Vernier caliper. In the very bottom side there is a one scale which is called as a Vernier scale, whereas the scale in the middle it is called the main scale. Here if you can able to see there is also a leads count written over there, but don't worry if you are not able to see. I will show how to calculate it and as well as how to take the readings on the Vernier scale. So look at here how many divisions are there on the Vernier scale. You can see there are exactly 50 divisions are there. We will see how to make use of those values or divisions. First of all, we will see the different uses of Vernier caliper. Here, these two things you can easily see in previous figure, but this probe-like structure at the bottom of the Vernier caliper is invisible. It is used to measure the depth. Here you can see this probe is inserted in any hole or trough-like surface or valley so that we can get the measurement of the depth of it. Whereas in this second middle figure, you can see we can measure the inner diameter of any hole. So it is for the inside diameter measurement, and in the last figure you can see for measuring the outside diameter, these two or large size projections are used. Now we will see the material used for the manufacturing of the Vernier caliper. There are number of alloys which can be used to manufacture Vernier caliper, but the material mostly used for the manufacturing of Vernier caliper is 440 grade stainless steel. Stainless steel is used to resist the stain, that means rust. It is suitable because of its superior wear resistance, hardness, and a high ultimate tensile strength, which makes it able to withstand high stresses. If we are using it for measuring a material or job of having higher hardness, then the dimension of Vernier caliper should not change. So we need the hardness. In addition, its ability to resist corrosion makes it popular choice. If it will be rusting, then definitely there will be a change in the dimensions of the Vernier caliper itself. So it is not desirable. So to avoid that, stainless steel is used. Stainless steel is further strengthened by heat treatment, by which its ability to resist permanent dents and lessens the impact of wear compared to other stainless steel alloys increases. Right? The treatment even improves the ultimate strength and tensile strength of the material. Even though it has earlier a higher hardness or let us say tensile strength, after the heat treatment, let us say hardening or annealing, any type of heat treatment which is employed there, it again improves its tensile strength. Now, what is the least count? It is the smallest value that an instrument can measure. For Vernier caliper, it is in our figure or the photograph which we have seen, it was the 0.01. We will see how to calculate. This is the formula to calculate the least count of Vernier caliper. It is given by S minus V is equal to S by N. Both either by S by N you can calculate least count or otherwise S minus V, where N is the number of division on the Vernier caliper, that is Vernier scale, and V is the length of one division of Vernier scale. That means the very lower scale, which is our side. Then S is the length of smallest main scale division. It is 1 mm, right? In our example. So total reading, how we will calculate? The main scale reading plus the Vernier scale reading multiplied by least count. Here let us say 10 mm is our main scale reading and Vernier scale reading is 15. Then we will get 10 plus 15 into 0.02. 0.02 is the least count. I think mistakenly I told you 0.01. It is actually 0.02. It is not the universal. It can be different for different instruments depending upon our requirements. But generally, which is asked in exam, it is a 0.02 means least count. Even the micrometers also have different least counts depending upon whether it is a digital micrometer or mechanical one. Just a minute. Okay. So we have seen this slide. The next instrument is micrometer. Here on the figure you can see that in this figure the nomenclature along with the main scale as well as the Vernier scale or micrometer scale. It is also called as a circular scale. Main scale is linear. Here this question is generally asked in examinations if you are preparing for GATE and PSU. The circular scale is nothing but the thimble, the scale on this thimble, whereas the linear scale means the main scale. Now here you can see there is an anvil and spindle. The spindle is movable with the help of this thimble. If we will rotate this thimble, the spindle will move to and fro in this direction. This space is used for the measuring. It is called as measuring space or holding the job. Sleeve with Vernier graduations. This portion is called sleeve, on which there is a main scale, which is a linear scale, whereas on thimble there is a circular scale. This is rough portion where there is a knurling operation is done. It is called ratchet. It is used for stopping the, what I can say, once if you hold a job here inside the anvil and spindle, and we will go on rotating this thimble. Once the job will be hold firmly and there will be no further movement possible, then this ratchet will start making some noise, like you can see whether it is a tick tick like sound or somewhere different maybe. This portion is called frame, and this is the lock. Once we hold firmly and our ratchet start making noise, then we have to lock this and take the reading. Then we will see how to take this reading. Here you can see list count for the micrometer is given by pitch divided by number of divisions on circular scale. On the circular scale there are 50 divisions, right, and pitch is 0.5 millimeter, and is the division number of divisions, right? So it will not have any unit, so only 0.5 mm divided by 50. So our final unit for the list count will be 0.01 mm. Mm will be the unit. This 50 does not have any unit. This is the number or the quantity of the divisions on the circular, that means on the thimble. Then how to take the dimension or measurement. So dimension to be measured will be equal to main scale reading plus thimble reading into list count, similar to the vernier caliper. Just here we are, instead of vernier scale reading, we are taking the thimble scale reading, that is circular scale reading. And material used for micrometer is generally made of cast steel or malleable cast iron. The anvil and spindle faces tipped with the tungsten carbide for increasing the hardness. That means because anvil and spindle will be continuously in contact with the measuring jobs or the material which we have to measure, if the hardness of this material which is to be measured is higher than the spindle or anvil, then it will wear the spindle material or anvil material. So our dimension will not be accurate. So it needs to be coated with tungsten carbide for increasing the hardness. Here you can see there is one example. Let us say we have hold a particular job in the thimble, what I can say, the measuring space, and we are getting these dimensions. So how to find the actual dimensions? Here you can see up to this 15 and 16 we are getting on linear scale 16 mm. Let us say main scale reading is 16. Now we will see which line is coinciding with this middle line of the vernier scale. Which line of this circular scale is coinciding with this horizontal scale, horizontal line. Here you can see this line is coinciding. Then we will measure after 20, because this larger line indicates the 20th division, then 21st, 22nd, 23rd. here we have got thimble reading equal to 23 and main scale reading was 16, right? And here you can see there is one more line we are able to see, that means this visible line is for 0.5 mm. So 16 plus 0.5 is equal to 16.5 mm. So by using this formula, here you can see properly, main scale reading is 16.5 plus thimble reading is 23 into the list count. List count is given 0.01. So we will get the final answer. Here we are getting 16.73 mm. What if this horizontal line is not coinciding with any of the horizontal lines on the circular scale? Then let us say such a condition is there. These white lines are the actual lines, let us say, and somewhere we are not getting any what I can say, coincidence, or the lines are not coinciding. Then in that case we will choose a reading in between. Let us say this is the line indicating the 25th division. Then we will take 25 or 26. Anything we can take. That will not hamper our measurement very greatly, because our main list count is 0.01 and our error will be lesser than that only, 0.01. So that is considerable. Now what is bore gauge? Here in the figure you can see that it is used to measure the inside diameter of any hole, let us say. You can see this dial indicator having a circular scale, and only if this probe is used, it is also used to measure the changes in the, let us say, surface. In the next figure you can see it properly. Here, if only this dial indicator is there, it converts this linear displacement. Let us say here is one surface at the bottom and we are moving this probe. This is the probe of this dial indicator. On this surface, let us say I am moving this probe. Then whatever be displacement up and down, that is linear displacement, it will be converted into the rotational movement of this dial to measure over a small range of movement for the plunger. This probe is called plunger. The typical list count that can be obtained is 0.01 mm to 0.001 mm. As I have told you that this is not fixed. This can be different according to the requirements and the instrument. Same, this dial indicator is associated in this assembly of the bore gauge. Now this linear distance will be measured on this circular scale. It is used for measuring the bore of different sizes ranging from small to large sizes. Right, this is the handle. Here we have to hold the bore gauge, and this will be the diameter of the bore. Now angular measurement. I think we should stop here, because angular measurement includes sine bar, then bevel protector, tri-square. Or should I complete it? Let us complete. We will discuss this thread measurement in next lecture. We will first complete the or else surface measurement and all we can cover in next lecture. We will discuss this angular measurement in details in the next lecture. Till then, if you have any doubt in the linear measurement, you can ask in comment box. Right? So I'm signing off for today. Thank you for watching the video. We'll meet in next lecture. Till then, you can welcome friends. In today's lecture, we are going to discuss different methods of linear measurement and angular measurement.